Thanks everyone for coming. I'm truly impressed to see so many people here because it absolutely doesn't match the way I attend conferences. The way I do it, I come for the first half of the day and then I pick the top speakers I want to attend. So I hope I'm one of those speakers you actually wanted to attend and didn't come here for by mistake. But even if you did, I hope you will all learn something. In this session, I just wanted to be a little bit more relaxed and get you to learn some bits and also get your minds thinking about more things that you don't usually spend time thinking during your day-to-day. So a little bit about myself. I'm currently employed at Salesforce. I'm working on Einstein machine learning platform. You might have heard of us over the media and over the years that we're presenting about it. I do software engineering for fun and profit. Obviously, my wife doesn't like me doing it for fun because it takes too much of a family time. I enjoy functional programming and good software practices. I put a star there because not necessarily everything that is good for me would be good for everyone. So it's very personal. But a lot of things where I do agree, and I hope during this presentation we'll see some things we actually do agree on. I'm a co-author of Transmogrify library. This is the library we open sourced on machine learning to automate a lot of your use cases on top of Spark. So you can go and check it out after. So what's on the agenda? If you would stand up now and go out, these are the things I want you to actually kind of take out of this talk. Is that I want us to think about more of a top-level things, more start small, think on the big problems, and then deliver them quickly. Don't over-optimize, over-engineer, and don't get stuck. I want us to be prepared to fail because that's part of the process, and I will talk about that a little bit in the context of Spark. Always ask for critical feedback from your peers and PMs and customers. This is the most important person you want to hear from. Well, person, I mean person in generic sense. Always explore and learn, and educate others around you, because this does pay off over time. And repeat that cycle. So always keep repeating it over the cycle of your product development. So, and this will be diluted with some personal thoughts and, of course, some real-life examples from my experience with Einstein platform and other projects I was working on. So what does it really mean to start small? Right? Kind of very obvious. But do we really even know how to do it? I keep asking myself over years, like, do we even have uninterrupted time where we can sit and focus and actually not get confused about the real problems and non-real problems? Can we differentiate them well? Do we even try to not over-deliver too much? I mean, I see it in so many projects where we as engineers, we try to, and we really want to do a lot of cool stuff, but this takes much more than we expect. And then, there's a critical issues with that. Projects are on fire, and we constantly delayed and so forth. We actually lack of experience of how to focus and think. I don't know if anyone studied this at college or anywhere. Maybe it's there is actually a study about it where, how to actually do it. There is no objective method. It's very subjective, so everyone has to develop his own or her own method of how to do it. And I'm not going to share how I do it. I can share some bits. What I do, I usually exercise, and then I just think in little short bursts and let my back mind think for me after it. But what do we know? Yes, we do actually need some systematic approach to solve problems. So whenever problem we want to solve, data problem or mail problem, we want to have a good systematic way of delivering the results. And then we want to go and keep improving on it. So really the algorithm that I was delivering to my team over years also, that we need to invest more time to understand and define the problems. The problems we usually solve, they're not really the problems we want to be solving. we actually want to look on the problems and on the solutions as well. And then we want to find flaws in those solutions. And when we find them, we want to go and document them and actually write them down. Because this actually gives us this memory over the, when we not just talked through this, through the meeting, but we actually wrote it down, and we had some deliberate action that we did, and parts of the solution and of the problem will be memorized. I can definitely guarantee that. So we actually need to go and talk to customers and PMs and use whiteboards. I don't know how many of you still use whiteboards outside the interviews. I think we should be using them more. Like really like gather together for small groups and just not brainstorm, but actually talk through the infrastructure, architectures and product like end to end or even specifics. We definitely don't do it often. And then, yes, we should definitely code it. So it's very, very easy to try things out. Software is so easy and cheap to try things out. So hackathons are really great for that. So it's part of each team to develop their own way of actually investing engineering time to prototypes and things like that. So for Spark in particular, it's very, very easy to fall into the rabbit hole of trying to solve dependency-specific problems and framework-specific problems and start fighting the runtime. It's never the case that you have everything running on your first day. Well, unless you follow in some very simple example and so forth. What you end up actually struggling with is the configuration and the runtime and just things that are not part of your problem that you're trying to solve. So I found like the simplest way of doing it, obviously there's Notebook and REPL and things like that. I actually prefer starting from a test. The reason to start from a test is actually it leaves some trace for you, future you, and your colleagues who will pick up this problem and will be able to run it, and it will stay in the code base as well. So in Spark, there are several facilities for you to do testing. I in particular, what was with Scala interface. And we use Scala Tests, and it's a great library to use, but you can probably use specs or something else. And all you need to do is, you add Spark dependencies, you add Scala Test and the peg down for the generators, for the report generation. And then let's say we have some estimator that we wanna test. Just for simplicity, I put a very simple min-max norm estimator that what it's doing, we want to write two functions there. One function is a fit function, and another function is a transform function. In the fit function, we receive a data set which we traverse, and we find the mean value and the max value. We want to keep them for the model. And then when the model is produced during the inference, we would apply the transform function, and we would transform the value using those mean and max values. I omitted a bunch of details, and I'm actually using the base classes for transmogrify library because actually Spark estimator classes would require you to specify several more functions. They wouldn't even fit into the slide. But let's say we want to write a test for it. So the test would pretty much look like this with a Scala test. You would need to extend some spec. In this case, I'm extending a flat spec with several matchers. I need to define a configuration for a Spark context. And then spool up a Spark session. So this usually happens once every time you run a spec, right? So for the most cases, you don't need to resume or whatever, restart sessions. If you do need that, then you can do something like before each, after each, something like this. So usually you spool up a Spark session, and then you want to write a simple case. Okay, I'm creating some little data set that consists of 4 points and feeding the estimator in it. And as a result, I'm expecting to get a model of certain type, and min-max values should be of a certain type. So far, so good. The things that we can actually start extending this example and reusing it for the other tests. Because we would usually have several similar patterns that use the same exact ideas everywhere. What we would also need, right, we would also probably need to shut down the Spark session and clear out the resources. If you're testing the checkpoints, that you would also need to create and delete your checkpoint temporary folder. Why not put it in some shared trait? So you can put a trait in which you can also add some extra stuff that you might need, and so forth. And this is how you can actually start small by creating those little snippets that you can reuse across your test. So here I'm also creating like a mixable trait and a base class for the Spark flat spec that also includes some definition for the, for example, in this case, for the cryo classes. And so how does it look? Yeah, we just can mix it in and use it in the test the same way we did before, but now it's more of a reusable pattern. If you want to look more about this, you can actually look at in the Spark code base. I borrowed some of the ideas from there. So unfortunately, it's not delivered as a part of artifact as a Spark. So, but the code is there, so you can look it up. After we did a test, right? So which is in our code base, and now we can keep it there for generations until the product specification change and so forth. We actually need to we need to think of a bigger problem. So maybe in this case, we tested an estimator, but what we're really building is a machine learning pipeline in which we need to apply actually a set of those estimators, set of those transformations for our data sets. So I put this image actually, it's like to emphasize on the short feedback loop, but I think it has actually much more meanings. As I like to think about software engineers that kind of eat themselves over time because we produce so much garbage code that we actually then maintain. So I don't know, and there are a lot of philosophies about the Ouroboros in general. But we really want to keep the short, very short loop, feedback loop when we develop, when we test things. But we want to verify that we have still a good solution that fits the problem. Obviously, we want to do some type check-in and check for logical issues if we can, which is not necessarily possible from something that you just develop in a notebook and you ship into production, of course. And the larger things then come in, such as troubleshooting and tuning performance issues. And again, we haven't discovered anything better than tests. If you can tell me that I didn't find anything better, then yes, definitely tell me. Like, just come after and then writing tests for actually verifying Spark for type issues and logical errors and so forth, the things I mentioned, it's actually pretty difficult because it's a difficult system. And there are many layers of software involved in there. So at this point, I kind of want to warn everyone, and it's not really kind of particular to Spark. I think it's particular to anything Hadoop or any other large system. You need to really evaluate if you really need to use that kind of complexity and introduce it into your stack. If you already have it and so forth, you already use it, yeah, and if it's well justified. For a lot of use cases, that might not be the case. So we have somewhat limited type checks for Scala and Java, and interfaces in Spark, they're not exactly type safe. So there's a lot of development that is done around data frames, of course, over the years to make them robust. But for machine learning pipelines, for example, that's far from the case. Very open interfaces for transformers and estimators and ML pipelines, very, very much error-prone and difficult to troubleshoot. We actually want to test on a variety and preferably real data sets. So maybe start from generating some random data and then use publicly open data sets from Kaggle or any other engine to discover data sets. Customer data is also great data to test, as long as you can have some robust checks on top of them that you can build. So some again tips on how to do it with Spark locally on your machines. So one of the tools I've been using, and Holden was just presenting here before me, is the Spark testing base that she developed. And it's nothing more than a thin wrapper on top of generators from Scala check, but with data frame interface. And we found them to be super useful to actually testing stuff. So And this would allow developers to test their Spark code with pseudo-random or randomly generated or controlled generated data. So the way it works is the following. Again, I'm starting here from a trait in which I'm creating some kind of data gen trait, which keep extending the previous trait that we had with the Spark context. What I'm adding here is I'm also adding the generator for the data set that would generate me some numbers from mean to max value of double type. And I'm also actually creating some random number of partitions for the data set, because some of you might know, some of you might not, but Spark behaves very differently depending on number of partitions and number of tasks. So ideally, this number should not be 10. You should actually jump something more than 200. For, again, not maybe for the unit test, maybe for the functional tests. And the way to use it is pretty much the same code as we had before, but now instead of the regular sequence that I had with the hard-coded values, now I'm using just the same data. Another difference is that I'm using here a special property check syntax. It's called for all, in which I'm saying basically for all values from a double generator, the following statement has to be true. And I also added an extra condition to check. If data is empty, then there should be some exception thrown. If it's not empty, I'm actually supposed to get some model out. OK, so we actually use this quite extensively for a lot of tests for our platform. So if you're interested, you can read more about Scala Tests, Scala Check. They have really good documentation. And Spark testing base is obviously open source. And actually, Spark itself has internally generators for mainly for RDDs, but they're still useful because you can pretty much convert RDDs to data frames. It does introduce some slowness. I think actually Holden's library wraps around the same, some of the random functions from Spark code base as well. So what about running on the real data sets? So this is the next step, right? You kind of wrote some small test for this random generated data. And then if you want to test it against production data sets or something real, you can actually add a couple extra plugins, also in this case, one extra plugin to do the Spark submit, which compiles and packs your code base together with your user code. And then you can, exactly as you do with the Spark submit binary, you can submit it directly from your build. So there is a nice plugin for SBT. We have actually a script for Gradle that you can use. Again, we're also using it very extensively for a lot of testing. So what about type safety? So type safety, it's actually somewhat a limiting factor to do any kind of robust platform development or building maintainable code. And with PySpark, for example, it's very difficult. There are some type checks that are present in Python. They're not present for PySpark. So an obvious choice would be using Java or Scala as an interface. But those are also not ideal. So here's an example of a transformer interface from Apache Spark, in which a transform function receives an untyped data set and returns a data frame, which is a data set of row, which means that transformer has a very open, can have a very open implementation of transform function. You can actually rename columns, you can drop rows, you can rename stuff, you can apply whatnot you can do. So it's actually very difficult without looking into the code base every time I look on a Spark transformer to know what it's actually doing with a data frame. They're all being written, obviously, by different people over a period of time, so they're actually doing different things. And some of them are dropping rows and swapping columns. And so there's actually a good library. Well, Transmograph I already mentioned, and which we're actually trying to solve that for machine learning in particular. There is now a library called Framelex, which you also might have heard, or whoever develops in Scala definitely heard of it. in which they trying to add compile time safety for data frame operations. And there's actually also now a section to do typed ML. So we might join forces eventually and mix with them. So what's there for troubleshooting and performance? So I actually personally love Visual VM tool, and it's a local tool which I use to just troubleshoot local Spark jobs. And with a beefy machine, you can actually troubleshoot it quite nicely and pull up multiple executors and verify and see what are your bottlenecks, and especially with things that with locks. If you happen to have some locks, and I don't know, for example, if you use Scala reflection, you would find that there are a lot of issues with concurrency around it. And Spark UI is obviously great, and looking on different tabs, such as storage that is being used by executors, and the executors tab is super useful, where you can look on each executor and evaluate the thread dump, and make sure that your code is not the one that is being locking the executor, and it's actually processing tasks. So yeah, obvious things to look for is memory usage on executors. It should match your expectations. So for example, if you persisted certain size data set, you should expect certain size of the data to be in memory, depending of course on how complex the data structure is. There is obviously an overhead, but you can usually roughly estimate what would be the allocation for the data set. Executor utilization is it's kind of fraction of how much memory it's actually used on the executor for to cache your data, and also by utilization I mean how many tasks the executor processes. Often you would see things like you would have a lot of executors just hanging there and only a few of them processing. So this would give you an indication that something is wrong. It's actually usually very difficult to troubleshoot. So with a lot of trial and error, you usually find the problem. So really prepare to fail, and I think this I also put because this is a list of facts. I think those are facts. For me, almost nothing works from a first try, first day. It usually takes several days until I actually figure things out, and that's fine. It's like this is just a part of a process. We have to face that it's part of the reality of software engineering to actually constantly be facing a wall. Every day you face one wall and another wall another day, and then you move on. So a lot of engineers ask me, like, how do you have this stamina? I'm like, I don't know. I'm just going to assume that this is the way it is. So if something, I don't know, some stupid things I wrote. Something seems wrong, it probably is. And yeah, if something seems correct, it's probably not. This is just the suspicious that you have to develop in yourself, that almost anything that you would use will probably break. And if it works, it's kind of a miracle that it works. So if anything was deployed and on the first day, hey, it's all working, well, no, probably you were not looking hard enough. So your failures are not my failures. This is in the sense that things that I experienced, they're not what the other peers experienced. And things I've seen will not be the exception, or even some exceptions that people experience will not be the same exceptions other people experience. So it's very important to actually maintain and bookkeep things. So we internally have a wiki in which we put exceptions and like what environment and as much information as we can about how the exception happened and what were the solutions that were taken to actually mitigate it. And this helps us a lot. Something like full text search index, it doesn't have to be complicated. There are a lot of open source solutions you can try for that. But really, like keep a good library of errors and failures that your team has. So for Spark in particular, Python and PySpark are okay for prototyping. I really don't like seeing them go into production. And when we do platform development, we have a very strict requirement of using typed languages such as Scala. So for us, it's an obvious choice because we cannot afford our our customers suffer because of our, whatever, spelling mistakes. And those are real things because Spark jobs, especially in large data sets, take a long time to run. So failures might occur 10 hours, 20 hours after you actually execute a job in production. So once you're in Scala, we found it very difficult to move forward. Well, leak abstraction is something that you probably overcome, but every single new developer that joins the team has to understand when looking on the code what happens on the driver and what happens on the executor. It's one example. There are other, of course. But this one is kind of one of the most, I guess, frequently misunderstood things that is happening. And then, of course, you have a bunch of issues that I will mention, some of them in the next few slides. Another thing is Spark codebase being maintained by so many people, and over years there are so many different parts of the code that different coding styles. But prevalent coding styles actually throw in exceptions, pretty much like any Java code base would do. To me, it's suboptimal, but we have to live with it. But then taking care of all the errors, it takes a lot of time when you start using Spark code base. And of course, dependencies, which are, there are a lot of them and they're outdated, so it bites us every time there is a new release. We have to spend a lot of time to making sure we evaluate them for the security assurance and so forth. And Scala and Java support is actually improving, so we're really happy about that. So here's a short Hall of Fame of Spark exceptions. I picked 3. One of them is task not serializable. I think everyone in this audience seen this error at least once. And if not, run more Spark jobs. You will see them. You can run the same one no, I don't know. Might appear. So yeah, a portion of your code cannot be serialized. What does it mean? It's a long story. I'm not going to get into that. But frankly, it says just basically part of your code cannot move from driver to executor. So Spark actually has a nice private utility, and you can actually access it by creating an object in the same namespace. So very, very easy trick. You can actually access hidden APIs in Spark like this. Definitely, I'm not encouraging you to do that, but in this particular case, it's super useful. And then you can use it early in your production application in which you would verify all your Lambda functions or whatever UDFs or transformers or estimators. You can actually verify that functions are serializable and fail very early. You don't fail, again, 10 hours after your job is in production. You can also put it as part of a test, right? So I can, what am I doing here? Yeah, so actually write the error that the function provides actually contains some information about which method is not serializable. So once you can identify it, you can go and try to make it serializable if you can. If you cannot, then you can end the problem. And then the only 2 solutions I found was to either create an object with that singleton instance, that is the offending instance that cannot be serialized, which then be initialized on every single executor when they try to access that same value, or actually go and create this instance every time inside the closure. So in this case, inside the UDF, I'm actually creating an instance of this non-serializable. Sometimes you don't want to do it. Let's say your non-serializable offender is the MySQL connection or Node.js connection or some other connection to external world. Then you probably want to use map partitions and just initialize that connection once on the partition, which at least will mitigate the overhead. Okay, another exception is Janina runtime exception. So Janina is a compiler that is used to compile your code every time you do any operations on data frame. It's an optimization. It was introduced, and it's actually, when it works lovely and beautifully well. In a lot of cases, it doesn't. So especially if you go outside any of the small, well-tuned, nice examples from the tutorials, any data frame that has more than 10 columns and I don't know, 10, 15 transformations would usually fall into those some issues with this. And if you have some complex UDFs, that's you very quickly get into those issues with Janino. And a lot of problems have been solved over years about this. So you can troubleshoot it by printing dataset schema, and also there is a debug method to do explain on the data frame, which will print out those logical, physical execution plans, and you will be able to see the projection. When the exception happens that Janino cannot, generate some method, there are a variety of exceptions like this. You can actually set a parameter to print it, so it will print out the full code, and I guess good luck finding the issue with that. Yeah, difficult. That's one of the difficult ones. So definitely not. I mean, one of the examples disable the whole code gen, whole stage code gen. Sorry, that's definitely not a solution because it makes your Spark run painfully slow. So what does work is that you can try to split your UDFs into portions and apply them on the data frame in 5, 10 UDFs at a time, depending on how well Janino works for you. It depends on the UDFs, of course, because you kind of have to tune it from problem to problem. And then in between, you would convert dataset to RDD, and then this RDD that you got, you can either persist or save it into, checkpoint it, and then convert it back to data frame. What this does, it actually breaks the catalyst. And this is the snippet that I put here. We actually use it in Transmogrify code to build 2,500 transformations on a single data frame, or it's sometimes even more. Works really well. And what we do, again, we don't like doing checkpointing because it requires I/O. For the most part, for us works, we just convert to RDD and then back to data frame. So in between those conversions, actually, Janino actually optimizes and creates those short projections of code. So we do benefit from the optimizations, some of the optimizations, and still be able to use it. Okay, so I think last exception is the container killed by Yarn. If whoever runs on Yarn would see this a lot, and what this really means is that there is actually not enough memory for your task to execute. Or it's also possible that something is mispartitioned, which is kind of easy to fix. What I've seen in a lot of cases also there's our own usage of some Spark APIs and serialization. So for the, what did I write here? So for the memory, it's actually very easy. You can just start bumping the memory a little bit at the beginning to just get yourself going. But it actually requires, it might buy you some time if your cluster have enough capacity, but what you really need to look into the key distribution and make sure your key distributes well across the partitions so the executors would receive good distribution of values. Sometimes you actually discover some problem in your data set where you have one key that receives 60% of the data and it falls into just a few number of partitions. Repartition the data set usually also works if you add some hash into the key. So yeah, cryo for serialization, it can be a topic on its own for the cryo, I guess. So the last thing is actually ask for critical feedback. Not everything is awesome. I'm coming from Russia originally, so for us it's actually more like an Eastern European style. I think we can actually add a new graph, like nothing is awesome. Like it's all snow. It's not all snow. But yeah, nothing is really awesome. Like really provide critical feedback for solutions of your peers and yourself. Like really be honest with yourself for the first thing, right? If some code is not ready for production, just really say so. Take more time, and I don't know, try to apply some of the principles to improve it. Yeah, step out of the comfort zone and learn to criticize your own work. I guess that said it. Finding people who actually provide you some feedback, and yes, better of some constructive sort, it's actually pretty difficult. Not necessarily possible within your organization. Well, I don't know, then move jobs. I don't know. Yeah, be patient, because some feedback is not great to listen, and I often hear a lot of bad feedback about my code, and yeah, it's fine. So yeah, for particularly for Spark, like pretty much everything you code in Spark can be written in at least 3 different ways, or might be more. I think this is just like theorem I put in there, and then 2 of them would be more efficient than your own version. And that's because of the APIs and the way things evolve in Spark. That sometimes you actually you can rethink your problems differently. Is that again, your first solution might use a bunch of shuffle jobs, and you do it in a set of MapReduce steps. But then suddenly someone comes and says, "Oh, you can broadcast this variable," and things become faster. Or, "Oh, stop using group by, start using reduce by key." And this just actually going and reading documentation helps. And I don't expect much. I mean, the code base is developed by so many people, so it just evolves. This is like the natural cycle of evolution for any software. Kind of the quality, I guess, degrades over time. Yeah, just I guess being ready to evaluate different approaches quickly, which means if you have unit tests, they would give you this velocity of operate quickly. If you change something, nothing breaks, you can move on. Without a test, I don't know what kind of assurance you have, except of the compiler. I guess the compiler is probably the only other guardian that we have. So to do that, you actually want to instrument some metrics, right? So you can actually go ahead and check that you didn't mess up with the performance, and Spark has good facilities to do it using Spark Listener. And if you're on ML, you probably want to instrument some regression tests on either well-known or customer data sets to verify every single release that you do. On top of the functional tests and unit tests, you would also use regression testing framework of some sort. I don't think it exists from Databricks offering or anything, but I hope it will be there one day. So for Spark Listener, there's like an open source project called Spark Measure that allows you to plug in a Spark Listener and collect a bunch of metrics. We also have our own similar version to it, kind of based on that, in which you can plug it in, attach it to your Spark context, and then in the end of your application, you would receive a bunch of metrics about how each single stage performed. So what you usually do with this is that you usually put an extra Spark job maybe to ETL over this job and deliver it to some dashboard. And then, of course, looking on the plot makes it much easier for us. Yeah, so I don't know, I read a lot of source code. This is what helps me learn, for example, and not necessarily just the Spark code base, but other code bases, Redis, Elasticsearch, Lucene, a lot of great projects out there. Definitely go ahead and read, and it will give you a good understanding about patterns of good and bad. And I guess the main thing is go and develop in your own programming style, because there is no one style that fits every single developer. To really fully understand, educate people around you, and this actually gives you a lot of karma in your orgs. And I don't know how much important is that. And I think technologists, that's another one pretty obvious. Right? Technologies change, but principles stay. So if you actually be able to understand and fully accept the principles of certain programming paradigms and best software practices, it actually grows beyond a certain framework. It goes beyond Spark or any other programming language. One last slide about our platform. So what I showed you, we actually apply to our platform, and we build a lot of machine learning applications for Salesforce. We currently run around 6 billion predictions per day using Spark and our own Transmogrify library that I mentioned before. And yeah, we're obviously hiring. And, yeah, thank you very much.